factoring polynomials. To factor a polynomial means to write it as a product of two or more polynomials. Remember, product means a multiplication. Factoring is the opposite of multiplication. So when you factor a polynomial, you're going to get back a multiplication problem. Our first technique of factoring is to find the greatest common factor and take it out of the polynomial. The greatest common factor, from now on we'll call it the GCF, is the biggest number or expression that divides evenly into the polynomial. Our first problem is to find the GCF of 24 and 40. So we want the biggest number that divides evenly into 24 and 40. I always try the lower one. Does it go into the larger one? If so, that will be your GCF. But 24 doesn't go evenly into 40, so we have to go lower than that. This is one that might come to you and it might not. Certainly there is a 2 in there because they're both even. There is a 4 in there. There is actually an 8 in there. And 8 is going to be the GCF because it's the largest. If you have difficulty finding it, what you can do is break to primes. So if we break to primes, we have 4 times 6, and we have 2 2's and a 2 and a 3. That's for 24. For 40, we have 4 times 10, and we have 2 2's. We have a 2 and a 5. Right, you're going to need the biggest thing that is common to both. So it has to be in both pieces to be used. The word common is important. Right? So for 2's, well, I have 3 2's in this one. I have 3 2's in the 40. Right? So those are common. For 3, I can't use a 3 because there's no 3 in the 40's factors. Right? I can't use a 5 because there's no 5 in 24's factors. So my GCF is 2 times 2 times 2, or 8. Our rule for variables is the GCF will be the least power of each common variable. So it still has to be common. It has to be in all the pieces, and you will take the one with the smallest exponent. So let's find the GCF for these two terms. First of all, for A's, we do have A in both, so it's common. You have to go with the lowest exponent. So we're going to go with A squared. For the B's, I have 1B here, 2B's here. It has to be the smallest, so we'll have 1B. For C's, this one has 3 C's, but no C's. So you cannot use C because it is not common. So our GCF is A squared B. Next, we'll look for the GCF of these three terms. And we'll kind of go in categories. So we have numbers, X's, Y's, and Z's. So first for our numbers, we have 6, 8, and 12. Try the 6. If it goes into both of the others, then that's your GCF. But 6 does not go into 8. So we're going to have to go lower than 6. Well, the other things that go into 6 are 3 and 2. 3 doesn't go into 8, so that's not going to work. So you're going to have to go with a 2. A 2 is obvious because each factor is even, but there might be something larger sometimes. But this time it is going to be a 2 for the numbers. For the X's, first term we have 5, second one we have 3, third one we have 2. You have to go with the lowest, so it will be an X squared. Third, we'll go with the Y's. So we have Y squared, Y cubed, Y to the 4th. Go with the lowest. It will be Y squared. And for the Z's, we have Z cubed, and Z to the 1st. It's going to have to be Z to the 1st. And that is our GCF. Next, we're going to look at some problems where we actually factor by taking out the GCF. So we look at our problem. It says factor it. Our first job is to find the GCF. So you can try the 8, but 8 doesn't go into 12, so you have to go lower than 8. How about a 4? 4 does go into both. Can we use an x? No, because there's no x in the second term. So a 4 is our GCF. We're pulling it out of those terms. It's going to go on the outside. You'll make one big set of parentheses. Inside your parentheses, you'll have as many terms as your original problem. So we're going to have 2 terms in here. Now we're going to see what do we have to multiply by 4 to get back 8x. So if we have 4, we want 8. Just divide. If you get stuck, it goes 2 times. So we need a 2. We also need the x. That would give us 8x. Right? Then we will do 4 into 12. We'll go 3. You do need the sign. Right? That is factored. It's a product. Your check is to multiply it back. And you should always check when the check is easy. Just you can do it in your head. This is 8x plus 12. So it's correct. Let's look at another problem to factor. So first we find our GCF. For the numbers, you can use a 5. 5 will go into 10, so 5 will be the GCF for the numbers. For your variables, you have y in both. You have to go with the lowest. So we can take a y squared, make one big set of parentheses. You're going to have 2 terms in your parentheses because you have 2 in the original. And now go term by term and see what's missing. The first term, you have the 5, so you're good. You have a y squared. You want a y cubed, so you're missing 1y to get 5y cubed. For the next term, we want back a minus 10. So we have 5. It will go into negative 10 or minus 10 and negative 2 times. Right, that gives the negative 10. We had y squared outside, so that gives us negative 10y squared. We don't need any y's on the inside. So we have factored. For our next problem, we only have variables, but that's okay. We can still look for a GCF. We do have x in both. We have to go with the lowest exponent. So x squared is our GCF. We're going to take it outside, use one set of parentheses, and see what's missing to get back to the original. So for the first term, I have x squared. I want x cubed. I need one more x. For the next term, I have x squared. I want a minus x squared. So it's going to be 9 minus. What number can we put here to multiply by x squared to get back x squared? You will have to put a 1. Because x squared times minus 1 will give minus x squared. Remember, you're going to have as many terms in here as the original. We'll try one more problem. We're going to factor out the GCF. So first we'll try the 9. Right? 9 does go into 18. It does not go into 15. It has to go into all of them. So we'll have to go lower than 9. So we could try a 3. Right? 3 goes into 9. 3 goes into 18. 3 goes into 15. So for our number, it is going to be a 3. For the A's, make sure you have A in each one. You do. Go with the lowest. For the B's, we have 1 B in each one. So 3a to the 4th b will be our GCF. Make one big set of parentheses. This time you're going to need 3 terms in there. So we go term by term to see what's missing. I have 3. I want a 9. We'll go 3 times. You have a to the 4th. That's all you want. You have a b. That's all you want. Right. For our next term, we want a minus 18 or a negative 18. Just divide 3 into negative 18. We'll go negative 6. We have a to the 4th. We want a to the 5th. So we need one more a, and we already have the b on the outside. All right, third term. We have 3. We want 15. It's going to go in there positive 5 times. You do need to put the positive to keep the terms separate. All right, we have 4 a's. We want 6, so we need 2 more a's. And we're good with the b. If your leading coefficient is negative, your GCF will be negative. So we're in descending order. Our coefficient of the first term is negative, so we're going to choose a negative GCF. So we're going to take negative. All right, try the 3. 3 goes into each thing, so we'll need a negative 3. Try the x. You're not allowed to use x because there's no x in the 12. Right, so negative 3 is our GCF. one big set of parentheses. You're going to have 3 terms inside, and be real careful with your signs. Right, for the first one, we already have the -3, so this one is missing the x squared. For the second term, just divide -3 into -9. It goes positive 3 times, and you need an x. For the last term, you have -3 into positive 12. We'll go a -4 times. Let's double check this by distributing back. So it will be -3x squared. That's good. -9x. And on our last term, positive 12. So what we did is correct. We'll try one more problem that starts out with a negative leading coefficient. So we're going to choose negative. We don't have any numbers there. We could write a 1 if we want to, but we're going to choose the negative. All right, let's check the variables. We're not allowed to take an x because there's no x in the other 2 terms. Check the y's. There's a y in this term, none here, so you can't take y's. It has to be in every term. But you could check the a's. You can't use a because it's not in the others. You can't use b because it's not in the others. And in the last term, we've already checked the y. You can't use the m because it's not in the other terms. So the only common factor is a -1. I'm going to go ahead and write the 1. I'm taking that out of each piece. So it's going to leave me an x squared y. Right? If you take the negative out of this term, it will leave you a negative ab squared. And for the last term, it will leave you a positive m squared y squared. Let's double check. This will be negative x squared y. 2 negatives will give us positive ab squared. And this will be negative m squared y squared. So that's correct. You will probably not see it with this 1 here, but if it helps you as you're going, put it. You might have to watch out in my math lab. They might not like it. Just going to rewrite it without. For our next couple of problems, we're going to find a binomial GCF. So it's bigger than what we're used to looking at. And this problem would say factor. We just are a little more specific here. If it says factor, in general, do not multiply it out. If we didn't see any words, we would multiply that as a distribution problem. Right. But it says find a binomial GCF. So we look to see what's the same in both pieces. And actually, it is just this big group. The a plus b is the same. So we will take that out. That is what we call a common binomial. Right? You still need to be able to get back to the term above. So one set of parentheses. You're going to have 2 things in this because you have 2 terms. Right? For the first term, we have the a plus b outside, so we're missing a 3x. For the second term, you have the a plus b on the outside. We're missing plus 2y. This is one I would not bother to check. To check it, you would have to do a FOIL here, and you would have to multiply the original. So it's a little bit too much work. For our next problem, we will also find a common binomial. When we look at it, the x plus 3 is the same. So that is our common part. We're going to pull it out of both pieces. Make your second set of parentheses. You're going to have 2 terms in it. This is 1 term, second term. All right, so for the first term, we have x plus 3 outside. We're missing the 2w. For the second term, you have the x plus 3 on the outside. You are missing the minus 5.